Welcome to today's Explainer. We're going to dive into something we literally all take for granted: how we stay cool. We're exploring the fascinating evolution of cooling down, looking at a narrative called The Architecture of Comfort, Seeking a Sustainable Chill. And honestly, what makes this specific deep dive so captivating is that we're looking at it all through the eyes of a 9-year-old girl named Asha. By following her school's science project, we're going to unpack some surprisingly profound truths about architecture, modern convenience, and our relationship with the environment. It's a fantastic journey, and I'm really excited to walk you through it. So let's kick things off with the exact question that sparked this whole investigation. Young Asha came home from science class and asked her mom, if ancient cities had underground cooling and water pipelines, why don't we do that now? I mean, it's such a simple, piercing question, isn't it? If our ancestors figured out how to beat the heat thousands of years ago using brilliant architectural design, why are we currently sweltering in modern concrete boxes? Well, Asha's mom didn't just hand her the answer. She challenged her to go out and figure it out for herself. Section 1. The Ancient Cooling Secret. Wisdom from the Past. Asha's science teacher actually planted the seed for this by showing the class 3 incredible ancient cooling features. And get this, they did it without a single electrical plug, motor, or chemical refrigerant. Ancient builders completely conquered the heat. They literally built entire cities underground to tap into the Earth's naturally cooler, much more stable temperatures. They used massive, high ceilings so hot air would naturally rise up and away from where people lived. And they engineered these intricate water pipelines that cooled the surrounding air just through natural evaporation. Nature essentially provided the blueprint, and early architects, they actually listened. Now, I absolutely love how her mom handled this. She encouraged Asha to act like a true scientist, using this wonderfully simple 4-step discovery process. First, ask that core question. Second, go out and survey the actual community around her. Third, dig deep into the historical origins of our modern cooling machines. And finally, draw a conclusion based on the total ecosystem impact. Is pretty much a perfect roadmap for our explainer today. Moving right along to Section 2, Perspectives on Staying Cool, the Street Level Survey. So Asha literally hit the streets with her notepad, and the data she gathered brilliantly illustrates that for everyday people, the quote-unquote solution to heat isn't a machine at all. It's actually highly contextual and behavioral. Her household help mentioned just relying on the natural shade of village trees. An auto driver simply drinks buttermilk to regulate his body temperature. A municipal worker actually adapts by shifting his hours to work at night during the summer. And the local traffic cop, he survives by tactically finding pockets of shade throughout his shift. People are adapting their behavior to nature rather than forcing nature to adapt to them. But it wasn't just behavioral adaptations that she found. Asha uncovered a massive architectural insight from a local construction worker. He pointed out that replacing traditional breathable bricks with modern cement is actively making our living environments hotter. He called it what it is: bad design. We basically swapped out materials that historically worked with the local climate for modern materials that trap heat. We are essentially building ourselves into giant thermal ovens. And adding to that structural insight, Asha's dad brought in a deeply philosophical layer to her project. He told her that relying on what he called flawed science, just for the sake of convenience, is spoiling the amazing balanced mechanisms that nature has already provided us. We've kind of traded long-term environmental harmony for the short-term, immediate gratification of just flipping a switch. And to totally validate her dad's point about nature's amazing provisions, Asha looked beyond humans. Even the local animals confirmed her street-level data. She noticed stray dogs panting with their tongues out to release body heat, and cattle intuitively and actively seeking out natural shade. Nature already has these built-in, highly effective mechanisms to survive the heat. The ecosystem already knows exactly what to do when the temperature spikes. Okay, Section 3, the accidental invention of AC, rethinking modern convenience. At first, Asha concluded that air conditioners were simply the enemy. But her mom wisely pushed her to look into the actual origins of the technology. And this is where it gets wild. The crucial historical twist is this: Willis Carrier, the inventor of modern air conditioning, didn't actually invent it for human comfort. His original intention was purely for industrial application. Specifically, he wanted to control humidity in a printing plant so the ink would dry correctly on the paper. Think about that. We took a machine designed to coddle industrial equipment and adapted it for our own personal convenience in our living rooms. When Asha shared this historical curveball, her mom pointed out that residential air conditioning doesn't exist in a vacuum. It's actually just one piece of a much larger societal trend. It's the exact same impulse that drives our reliance on ready-to-eat meals, highly processed foods, and jumping into cars and buses instead of walking. Residential AC is just part of this broader shift toward engineering our surroundings for maximum ease, often at the expense of natural harmony. But to be completely fair and impartial, Asha's mom also correctly noted that air conditioning provides substantial, undeniable benefits. We can't just ignore them. It enables people to work comfortably and productively for much longer hours, which drives modern economies. And it's absolutely vital for preserving priceless historical artifacts in museums around the world. So the technology itself isn't inherently evil, it's incredibly useful. Which brings us to our final section, Section 4, Engineering a Sustainable Chill, Designing for the Ecosystem. Taking in absolutely everything she learned, from the construction worker, the animals, and the history of Willis Carrier, Asha reaches this remarkably mature realization for a 9-year-old. It's not about old versus new methods. It's about constantly creating better methods. We can't just abandon all technology and move back into caves. But we also can't blindly rely on heavily polluting designs just because they're convenient. The answer isn't regression. The answer is forward-thinking innovation. She basically defines the ultimate goal of structural design moving forward. Let's call it ecosystem-centric engineering. It means providing the intended benefits, like keeping us comfortably cool and productive, but doing it with no harmful effects to the entire surrounding ecosystem. It's about creating cooling solutions that work in perfect, synergistic harmony with the environment, rather than aggressively fighting against it with brute mechanical force. So, as we wrap up this explainer, I want to leave you with a final provocative thought. Are we prioritizing our own immediate convenience over the health of the ecosystem? And more importantly, how do we design a better, more sustainable chill for the future? I really want you to think about that the next time you instinctively reach for the thermostat. Thank you so much for joining me today, and keep exploring.